Good day. I'm here to continue my discussion with regard to the subnetting principles. As promised last time, I'll be giving another example for us to be able to fully understand how to use the subnetting process. So for this example, I have a question here or a sample problem given an IP address of 198.36.12.0. Use subnetting to divide a network into 12 subnets. Determine the maximum number of hosts per subnet. So we'll use although we could solve this with a number of steps, we'll use the steps provided in the handouts so that we'll get used to the proper subnetting process. So let's go back to the handout just to determine the steps that we need. First, we need to be able to determine the class and the default masks of the IP address you have been given. So the IP address given is shown to be 198.36.12.0. From our previous studies, we should already have determined that because the first octet is 198, that means that this is class C address. So being a class C address, it would have a subnet masks having /24, or the first three octets are all ones. So in decimal, that would be 255.255.255.0. In binary, that would be three sets of ones and one set of 8 zeros. Three sets of 8 ones, or three octets, and a set of zeros. So this would be our subnet masks. So this would be our step 1. Next, our second step involves identifying the number of subnetworks that are required. So from the given, it was clearly defined that it was asked that we divide the subnets into 12. So our answer for here, for step 2, would be 12 subnets. Step 3 asks us to determine how many bits are required to support the total number of subnets. So if you can remember correctly, in order to be able to determine the number of bits that we need to borrow from the host ID to turn into a subnet field or subnet ID, we need to determine, or we need to convert our decimal number or the number of subnets into binary. So we'll use the continuous subtraction for this process. You could also use continuous division as well. So we'll set up our subtraction here, and then let's set up our octet here. So we have 128, then 64, 32, 16, 8, 4, 2, and 1. So we start with 12 to set up the subtraction. So among the powers of 2, the largest power of 2 without going over 12 would be 8. So that means we don't have 128. We also don't have 64. We don't have 32. And we don't have 16. Okay. Now we do have 8. Okay? So 12 minus 8 would be 4. The next power of 2 that we could subtract from it is of course 4. And then we stop because we already have 0. So we put a 1 to represent 4. And because we had to stop already, the remaining powers of 2 would be assigned a bit of 0. Now, just like with decimal numbers, we really don't write the left-hand zeros. So that means in order to represent 12, that would be 1, 1, 0, 0 in binary. Okay? So that means we just need to borrow 4 bits from our host ID in order to represent the or to be able to cover all of the required number of bits for the subnetworks. Next we go to step 4. Step 4 is asking us to determine the custom subnet mask for our network by masking. So we already have our network mask from step 1, or the default mask from step 1, which is this. Okay. So what we're going to do is we're going to borrow 4 bits from the host ID. Again, when we borrow bits from the host ID to turn into a subnet ID, we use the left bits first of the host ID. So because this is class C, all the 3 octets having 1s are part of the host ID. The ones with the last octet having 0s determines the host ID. So we need to borrow 4 of them. So that means the first 4 here, to be able to facilitate the 12 subnetworks, has to be turned into a subnet ID. So this would now be our answer for step 4, which is the custom subnet masks. Now, step 5 asks us to determine the lists of the viable IP addresses given our subnet masks. Okay? So, before we go to step 5, let me go back to step 4. Let us convert our subnet masks into its decimal notation. The first 3 would still be 255, but we need to convert this one into decimal. So what we usually do is, again, we assign the powers of 2 over the decimal portion. Well, there are many ways to convert binary or binary to decimal, decimal to binary. What I'm trying to do is using continuous addition. Okay? So we have ones for 128, 32, and 16, and zeros for 8, 4, 2, and 1. So that would mean I have 128 plus 64 plus 32 plus 16. So this would result in a sum of, so 128, 64, so that would be 188, 192, 192, 222, 224, 240. Hopefully I'm correct. I don't have 8421, which results into 15. Yeah. Maximum would be 255. So this is correct. So that means our subnet ID or the custom subnet masks would be 255.255.255.240. Now let's go to step 5, which asks us to list the possible subnetworks. Remember that our last portion here, so if we go back to our previous example, in order to determine how we go to this is we look at the last possible portion, which is equal to the powers of 2. The third position or place value is equal to 4. So we still have the original host ID or the network ID here, 138.45. That 0.0 is not a valid subnetwork. And because this place value here is 4, the subnets increments by 4. Going back to our sample problem, so our last subnet or our last one here represents or actually represents 16. So that would mean, I'm talking about this one because there are 4 ones. So the last part is 16. So if we try to list everything down, we still follow the first 3 numbers of the original IP address, 198.36.12. Again, the .0 is not a valid subnet. So how about the next one? So 198.36.12.16. And then we go to the next one, which is 32. Then 48. Then 64, so on and so forth, up until we reach the last possible subnet ID. Remember, when we look at the list of the subnet ID, we cannot use 252 as a custom subnet mask value. So it's not a valid subnetwork address. So this is, so it would be 32 below the original or the maximum subnet mask. The maximum here is supposed to be 255. So 252, 253, 254, 255. Okay? And then 248, 249, 250, 251. So that would be around 7 below. So in this case, we have 16. So the maximum that we could have, so we cannot use 240. Okay, so that is not acceptable. That is another subnet we cannot use, custom subnet we cannot use. So the last usable subnet would be around 224. Oops, let me correct that. So let me go ahead and check that. So we have here 248, 249, 250, 251. So that's the last possible subnet for our previous example. Then 252, 253, 254, 255. Okay. So that would be minus 30, minus 7, not minus 8. So this would be minus 31. It's supposed to be minus 31 from 255. So it is 224. It's the last possible subnets. Okay? Incrementing by 16. Now the number of subnets possible is actually given, although we only need to fill up 12 subnets, we actually have more than 12 subnets that we could use. We use the formula 2 raised to n being the number of bits in the subnet ID, minus 2. Again, the 2 that we are subtracting, oops, it's here, actually comes from the first subnet ID and the last, which is not usable. So that would mean, because we borrowed 4 subnets, or 4 bits for the subnets, minus 2, so we have 2 raised to 4. So that would be 2, 4, 8, and 16. Okay? So we have 16 minus 2, so the maximum would be 14. So that means we still have 2 extra subnets that we may use as a sub network. Now, step 6 involves listing. Oh, that was our answer for step 6. I got ahead of myself thinking it was part of step 5. So this would be our step 6. Okay? Listing or determining the number of subnets. Step 7 is asking us how many hosts we could accommodate per subnets. So the last step involves looking into the remaining number of bits used for the hosts. So if we look at our custom subnet masks, we still have 4 bits from the original octet that can be used for the number of hosts. So, with that being said, it has the same formula as step 6. So we use 2 raised to n minus 2. The n here being not the number of bits borrowed for the subnet, but the number of bits remaining after we remove the subnet, or the bits used for the subnet. So that would be still 4. We use minus 2 because we don't use the last and the first host's ID. So we still have 16 minus 2 equal to 14, giving us a maximum of 14 hosts per subnet. Okay, so that will be the last step. Hopefully you were able to have a deeper understanding of the subnetting process. Hopefully you'll be able to use this in your upcoming lessons and whatever you want to learn in networking. If you have any questions, or if you want to place any corrections from what I was able to do, don't hesitate to write that in the comments. And thank you very much. See you in the next lesson.